Here we go. We're at 212, and we're doing equations. An equation is an algebraic sentence stating that two expressions are equal. And we actually just talked about that when we were doing our representing our values algebraically. If you had like D equals RT, this is an equation because this side over here has an equal. And so when we're talking about sides with equations, we're talking about the left side of the equal and the right side of the equal. Okay? So, an equation is perhaps the single most powerful tool in algebra, providing a way to find values for variables. An equation works like a balance scale. Whatever operation is done on one side, it must also be done on the other to maintain the equality or balance. And so that they have a really good pictures here. So I'm not going to be able to be as like artistically accurate, but so if you had something on this side, and like they have, it's like 50 pounds, 50 ounces, 50 something. And if I had that same amount on this side, then they'd be equal, right?
Right.
And if I added something onto this side, to keep it from tipping, what would I have to do to the other side?
You'd have to add to the other side.
I'd have to add that exact same amount. So if I added, let's say, 10 on this side, I'd also have to put 10 on this side so that it wouldn't tip over, right?
Right.
What if I took that 10 off of this side? What would I have to do to the other side so it wouldn't tip?
What would you have to do to this side? Take it off.
You'd also. So that's exactly how equations work. If I add something to one side, I have to do it to the other side so it doesn't tip. Now, what if I had this 50 on each side, and what if I cut it in half? So I only now had 25 left. What would I have to do to this side?
Cut it in half.
I'd also have to cut this in half so that I had 25 again. So to keep it balanced, okay? What if I had, let's do different numbers besides 25. What if I had, let's do it really small, like 2. And 2 on this side also. Didn't have to erase this one. And instead of, so I've done addition, I've done subtraction, I've done division by dividing in half. What if I multiply and I double this? And multiplication basically is just addition. So if I double it, I add another this of the same amount, right? I have to again add the same amount again.
Right.
So to double or I'd triple or quadruple, or I'd have to multiply on the same side and to keep it even. And that's the total essence of equations. This is a very simplified version, but what if I do this? What if I had let's do another analogy here with equations. What if I had a 3 pounds and a 2 pounds, and I had a 3 pounds and a 2 pounds? Does it matter if I have them on top of each other? No, because they have a total of 5 on this side, right? And so if I rearranged these over here, if I switched these around, it wouldn't change how the equation goes, okay? And so we're going to actually see that eventually in your equations. I can add something to both sides, subtract from both sides, cut it in half on both sides, double it or triple it or quadruple it or multiply by anything on either side. Or I can rearrange on one side and not have to do anything on the other side. Because if I just turn these around any direction I want, as long as they stay on the pan, it doesn't matter what order they're in here. Okay, and we're going to be rearranging, and as long as I rearrange on one side, I don't really have to rearrange on the other, because it's going to be the same weight on both sides, okay? All right, so let's solve some equations. Turn the page there. And we'll start off with 2x plus 3 equals 17, okay? And so our goal is to have x equals a number, okay? So we want to move the 3, and we want to move the 2 to the other side, okay? And so since we're adding to this side and multiplying, we usually go backwards to the order of operations. Order of operations, when we were doing expressions, told us that we did multiplication first and addition and subtraction last. But since we're kind of like undoing this and trying to take it apart, we're going to go backwards. So we're going to move that 3 to the other side. And since we're adding on this side, we're going to subtract it. And since we did it on one side of the equation, we do it to the other. So we'll bring down that 2x. And 17 minus 3 is?
Sorry, I drew a blank. 14.
It's all right. And then I'm going to have to squeeze this up because I'm going to run out of room. This is 2 times x, so I'm going to divide both sides by 2 to get that 2 there, because we're going to do the opposite of what we normally do. Okay, so this is multiplying, so to undo it, I divide.
Okay.
So I'm going to divide this side also by 2, because we said that with equations. So those reduce out, left with x, that's what our goal, and 14 is 7. Okay, and you have seen these before. We've done equations before, so I went a little faster than I would be. Now the cool thing is they actually check this, and that's very important. We started off with 2x plus 3 equals 17, and you should always really check this to see that really x really is what I wanted to get. And so what I do is I can plug it back in there for x. Is x really 7? Is 2 times 7 plus 3, does that really equal 17? And so this is 14. And plus 3 more is 17. So 17 equals 17 is true. So x is 7.
Okay.
Okay? All right. Let's try one a little more complicated. X over 5 minus 64 equals negative 61. You're going to see negatives and positives.
Okay.
And so we have that 64 that needs to leave, and we have our 5 that needs to leave. Okay?
Okay.
We're going to move the 64 first because it's all by itself out there. The one with the variable we're going to do last.
So we add 64.
So we add 64. Good job.
We'll add 64 on that side.
Right. Since we did it on one side, keep it balanced, we have to do that. Our x over 5 is still there.
And then that will turn to 3.
3. Good job. This is x divided by 5.
So then
multiply by 5. Good job. So we're going to multiply by 5 on both sides. These reduce out.